Hello and welcome, developers. My name is Shay, and this is another episode of Shay Develops. Today, we're going to be talking about interfaces in Java and how they work and how they help determine what our class is able to do. So if you're not familiar with an interface, and that's totally fine if you're not, that's what this video is for. An interface allows us to declare behavior to a class that implements the interface, but it doesn't instantiate the behavior or say how the behavior is going to act in that class. It just says, hey, you need this behavior, but how you use that behavior is totally in and up to the class that's implementing it. So in order to get this started, we're going to create a class and we're going to create an interface, and we're going to have that class extend the interface. And that's important to remember here, because whenever you're creating these, you can't, an interface doesn't extend a class. It gets implemented by a class, okay? So keep that in mind. So let's go ahead and create a new Java class. And we have class and interface here. We want to select interface. We're going to call it iMove. And we're using the I here so that way whenever we're looking at our classes, we can easily set like, oh, that's an interface, okay? And it just quick reference for visually. But however, you also notice that we have this little green circle with an I in it, and that's IntelliJ's way of telling, hey, this is an interface file that we've called iMove. All right, so what actually do we want to do with this? Well, we can do quite a bit with it, but basically we want to tell the class that we're going to allow to use this, which could be a lot of things move, right? People move, cars move, animals move, all kinds of stuff moves. So we could use this on a lot of things. But what do we want, to actually be able to tell our class that's going to be implemented? What methods do we want it to have to create in order to be able to move? And we're going to keep this, as I said, pretty simple, but let's start out with, and also keep in mind, whenever we're creating an instance, everything that we're passing to it is going to be public. Now that does change with Java 8 and Java 9. You can create default methods and private methods and stuff like that, but we're not going to be doing that here. But we are going to be creating, like I said, I do want to mention that as far as, because it may show up, you'll be like, oh, I thought all methods in a interface had to be public. Well, that is mostly true, but there is some certain things that was brought about in with Java 8 and 9 that changed that a little bit, but for the most part, they all still work exactly the same. So let's go ahead and create, like I said, our first method and how that's going to work. And it's super simple code here. Basically, it's just void, because we don't want it to return anything, right? That's our keyword for not wanting it to return anything. Void move. And that's it. That's how we tell the class that's going to implement this interface what its method should be called. Like I said, it doesn't actually do anything. It's just saying, hey, you were going to implement this method that's going to be called move. Now, like I said, if you're putting it into a car, the car is going to have to, turn on the engine, press the acceleration. The motor is going to do its thing, transfer power down to the driveline and to the wheels, and it's going to move that way. But say human is just going to, activate their leg muscles and take a step in a forward direction, or move their arms, or a whole bunch of other, move can mean a lot of things. But that's basically how this is going to work out here. Now, and also remember that all these methods that we're creating are abstract. And we're going to be talking about abstraction later. in another video whenever I go back into object-oriented programming properties. Like I said, I already created one on inheritance, and then another one on polymorphism. But we're going, like I said, we're going to have some more that are coming down the line. So we got void move, like I said, and this is I move. And say we had like something else like a phone or something like that. A phone, we could have ones that were like, okay, void does the phone on. So void on. We could do void answer, all kinds of different stuff there if you want to do that. And that might have been a better example, but we're going to stick with the move. I think keeping it as simple as possible is good. So we've created our interface with this void move method that we want to do. So now we need to right click and we're going to create another Java class, and we're going to call this car Java class. Now our car is going to have a few fields like private, let's say string make, private string model, private int year, and we'll leave it at that, right? But so far, like I said, we haven't done anything with our iMove interface yet. We have to implement it first. So we're going to use the keyword implements, and then you need to tell it what it wants to implement. Well, we want to implement iMove, and we'll see that in our little drop-down list right there. iMove. Now it doesn't like this because we haven't instantiated the move method that it wants. So we could come down here and do alt insert implement methods right here. We control I if you want to go right to it, and we implement it from our moves interface. So right click, and now we've overridden the move method that we have here. So what we could do then is just output some text. The car is turning its wheels to move. But yet still now we still have some other things that we have to do. Of course, in our classes we need to put in a constructor and do that. So whenever we go now to our main method, let's see how movable works, or move works. So we're going to do car, we'll call it a Honda equals new car, and we have to pass our parameters of our constructor, right? So it's make is a Honda, our model, we'll call it a Civic, and the year is a 2019. Alright, so now that we have our new car, we have Honda, and we can do Honda.move. And that isn't necessarily just calling it from our car class, but then it's going back and, like I said, it's making sure that we're instantiating it from our interface itself. And you might be thinking, okay, yeah, but why do I even need to have an interface if I'm just creating it right here within my car class? And it's just to make sure that we are keeping we're providing a set definition of a way to do something, easily without having to recreate it or remember it each time that we're creating something that has move capabilities, right? All right, so we're going to run that class. Let's go ahead and run this, and it's going to output it to our command line. Go ahead and build it real quick. Boom, it says the car is turning its wheels to move, which is coming from or override the cars right here within our method that we created. Now, within our interface, we can also have variables as well, and this may or may not be beneficial. Now, whenever you define a variable in an interface, they are implicitly public, static, and final, meaning that once you define it, it cannot, or once you define and then instantiate it, it cannot be changed. So something like int speed equals 2 is the same as public static final int speed 2 equals 4. These two are exactly the same. So you see how all these are gray. It's just meaning that that is redundant and we don't actually need that information. Now, the bad side to this, like I said, if we have this speed here and we wanted to define speed here, let's make it private final int speed, and we'll say equal to 6. If we were to call speed here, we don't know exactly which one it's going to run. So let's go ahead and run this to see what happens. And it returned 6, which makes sense because it's inside of its class that it wants to implement. But if we were to do imove.speed, and that way we're explicitly telling it which one we want it to run. We're telling it now that it's 2. So you may want to do this, and like I said, you may not. But usually, though, you are not going to define some variables within your interface unless they're not going to change and they don't necessarily need to be overwritten whenever you're creating the interface within the class. And also keep in mind that these things, like I said, they were public. They cannot be private. That is not allowed because you're not actually doing anything with the fields and the methods that you're creating. You're just declaring them and giving them a name. So say we wanted to have a method that returns something. Let's do return a boolean that says is alive. So now a car isn't alive, but we can do, it could be is working. So it said, now that I've created that method though, says we back now have this error. So we need to hit Control I to bring up our methods that we want to implement via our interface. So hit OK, and return is alive. It's going to automatically return false. But we can just go ahead and make that return true because the vehicle is going to be alive unless the motor's dead or something like that. But I just wanted to show you guys a way that said you can create something that determines whether, or create something that returns a value, not necessarily just a void. And you could also pass this a boolean, it'll be a alive, and that we could pass in a true or false value that then returns if it's true or false. So boolean alive, and we could do if alive vehicle, or the car is live. That's if car is dead. You return true. Really, this one you could just return void, or not return void, but just make it a void method, and that would work. Probably even better, but for now we'll just leave it like this. So now we have another method that returns boolean if something is alive or not. So go back to our main. We got Honda.move. We can now do Honda.isAlive and pass it true. And now we got the car is alive. Now let's create another class, something totally different. We'll make it a bird. Now a bird moves. All right, so we can implement our move. iMove. We'll do private string name and private string, or actually private boolean flies, and we'll go ahead and build out our constructor. And then now we need to implement our methods from our iMove, which is move and is alive. So we ask out the bird is flapping its wings. And then we could probably go ahead and grab this from our car class. Now this might be a little morbid what I'm about to write, hopefully not. It says the bird is alive and can move. The bird is not alive and cannot move. All right. So that way, whenever we come now back into our main method, we could do create, and we could declare and instantiate our bird class. We got bird, we'll just call it bird1. I don't know a whole lot about birds, but I just played a bird card game with some friends, and I had that on the mind for some reason. So new bird. So we have to give it a name. We'll call it Big Bird. Sure, Big Bird. And if it flies or not. Big Bird does not fly, so it would be false. So really, we could have made this a little bit better rather than, so is alive. We could also create an override a flies method. So if we wanted to put that in here, it'd be like void flies. And then we would have to now bring that into the car and say, hey, car does not fly. Or we could bring that into the bird and be like, oh, based off of the value of our bird, or the value of if the bird flies or not. We could say in move, since the bird flies, the bird can fly rather than walk on the ground. But I'm going to go ahead and remove that for now. And this video is getting a little long. I'm sorry about that. But now we can now do bird1.move, and we can see how we can use the same method declaration to then make sure that we're creating the same methods within our classes that we want to be able to use, or that we need within these classes that say they move or whatever it is that needs to happen. Alright guys, so hopefully y'all learned something about interfaces today, and you don't just thinking that this is something that's just not very useful, because it really is. It helps abstract our data to where we are, or abstract our methods and stuff that we're not writing the same code over and over and over again, and we're making sure that things are, not necessarily the same, but they have the same methods from class to class to class where applicable whenever we're writing our code. So that helps, you know, as far as like keeping things in line with each other, and helps developers down the line whenever you're trying to call these methods and stuff. Like, oh, okay, I see that this method or this class implements this this interface, and that's, you know, all. And so I know it's going to have access to these methods. And one thing, real quick, that I forgot to mention, if we were to create another interface called I breathe, which a car breathes, not in the same way, obviously, as me, you, or any other living thing, but a car does breathe through their intake system, because if not, they would overheat and stuff like that. But we could call I breathe, and then void breathes, and then we could actually implement another one on top of I move, so we can do I breathe, and then make sure that we implement the methods within I breathe. Oh, I forgot how the car breathes. I just said it just a second ago. Anyway, but we can implement the fact that we can implement multiple interfaces by using this comma and then stating the name of our interfaces on top of each other. And now also, interfaces can extend other interfaces. So if iMove wants to use, iMove wants to use the iBreathe interface as well, we can use the extends keyword and then do iBreathe, and then now it has access to the iBreathe methods. This would be breathes, and now see, we're overriding it from I breathe. Alright, so hopefully you guys, like I said, have learned something. I know that was kind of a longer video, but if you did, please like, comment, subscribe, hit that notification icon, hit me up in the comments. I'd be happy to talk to you, see what you guys are working on, see what you're trying to learn. Tell me how I can do better. Tell me a video that you're wanting to see. So rather than like these short videos on smaller Java concepts, I can create a much bigger one where we actually create, you know, an actual program, and then go back, as I said, and use some of these concepts within while creating the program. I've got some, like I said, but I've got a lot of videos that I'm going to be recording in the future, but I can always change it up. Just depends on what you guys want and what you guys are trying to learn. But y'all are awesome. I hope y'all have a great day, and I'll see you in another video very soon.